Welcome back to part 3 of Unity with Notorous Hex and Tile Grids. In this episode we're going to add some directions to our grid manager, as well as creating a bounding box around our grid. We'll probably use the bounding box later for maybe some camera bumpers. Anyways, so we're going to go ahead and create walls method. We're going to create a create walls method and start creating the bounding box around the grid manager, which should encompass all the tiles themselves. So we're going to go ahead and start with a local variable wall game object. What we're really going to do is just create a new game object, add a collider object to it, and move it to the right location. So we're going to create, kind of one wall, and then we're just going to copy and paste it 3 additional times to create 4 walls and modify a couple of items. We're also going to add the walls to a particular layer in case we want to use layers later on to ensure that the camera bumps into them, for example. So here we are adding it to a particular layer. We will need to create that layer. Wall colliders is the layer name that we're going to give it. Click something in your hierarchy, add layer, and then the layer number in this particular case doesn't really matter. So we create the layer, we call the layer name to layer option, which allows us to use the name instead of the number identifier. What we're going to do is build some of the math required to create and move the wall itself to the correct location. Basically taking in the grid width, or the total grid width, and adding a little bit of modifier there based on the offset. Here we're going to grab the transform of the game object and feed it into the position. That's the game object that we just created. Notice how I selected new on the log go game variable. Need to add the size in here as well. We don't want it to be a tiny little box, so we need to size it appropriately. We're adding the box collider game object, the box collider component, I should say. Then we set the size, then we set the position. There we go. Size, I'm guessing about 0.5 width, 20 in height. Plus 10 is just a ballpark in terms of the offset that I feel that I need. We will parent this to the game board manager. we need to do is just copy this 3 additional times. We will need to add a rotation on 2 of them, so they rotate 90 degrees. But for the most part, I will need to make one other modification to the X and Y axis, but otherwise they're identical. So I'm just copy and pasting it right now, rearranging some stuff so it all fits. So here, notice it's a wall 1. We'll go ahead and change it to wall 2. We'll just call it wall 1, 2, 3, and 4. So we change that. The other item we need to change is right here. Where is it? Oh, here's the. Oh, we'll just do the rotation. Rotate it 90 degrees, so that should be good. So we'll just highlight both of these and not comment them, but highlight them and copy them. For some reason I'm getting a double copy or paste, so that's why you're seeing a double and then me deleting it, but nevertheless I'm only putting it in here once. And connect that over to the new wall game object, make that 3 and 4 respectively. There we go. And then what we need to do is just add a minus value here on the z-axis. We need to do that on the other z-axis as well, I believe. There we go. Let's see what we get. Oh, we have to actually call the method. It wasn't actually being created at all, so they weren't there. So let's go ahead and add create walls method. Now it'll actually be called. I guess we could put a Boolean value in there to say walls on or off, but I think at this point it's pretty benign. There they are. 1, 2, 3, 4. Oh, looks like our vertical walls are off a bit. Let's check that out. There we go. I connected to the z value. It should have been the x value. There's where I went wrong. There we go. Those two areas, so move the walls. Great. Good, the walls are surrounding our box or our game manager cubes or grid of hexes. Awesome. So we'll use that as a bumper potentially in the future. Excuse me. Anyways, now what we want to do is modify the start statement so we add some directions for our tiles, or basically the game manager is going to set up a set of direction based on if it's you know, squares or hexes, and based on if it's a 4-way movement of squares or an 8-way movement of squares, and we'll get some specific directions based on what we want there. And we'll define those directions, and then on a future tutorial we'll go ahead and find the neighbors of each of the hexes or squares depending on what they are based on those directions. So what we're going to do is add some of the information that we need here based on if it's going to be a diagonal movement, a hex, or not. So we'll need to make sure those run first, and we'll add this in here for if it's a hex or not, and then the next we'll also add an if statement in on if it's a directional movement or not. So we will need a directions variable, and it will be a vector 2. There we go. So here we'll need to create a new Boolean value is diagonal movement enabled or something like that. So we'll change that. When this is finished, it'll call that. We'll make sure that runs, but we will want to shoot over to a different area for if it's a hex movement. So what we're going to do is set up the directions for the square 4-way movement, square 8-way movement, and the hex 6-way movement. So what we want to do is make sure that we keep an eye on these array or list indexes. I notice they do zero out if you modify really anything regarding the array at all, or the list, or whatever you're doing with the get and set array element. So be aware that it does reset itself if you change anything, and you'll have to go back. And usually I go back and double check just to make sure that's not reset somehow every once in a while. If you get some bizarre error, that's probably the first area you want to check. So of course array starts with 0. We're going to have 8 of them here, 4 in the first one, 8 in the second one for an 8-way movement. And the index is 0 through 7 on the 8-way movement, 0 through 3 on the 4-way movement, and then 0 through 5 on the 6-way movement for the hex. So hook this up here, diag. And we'll need to rearrange this a little bit. Hang on. We'll put the hex stuff over here separately. Just double checking those again to make sure they're correct. We'll go ahead and link all these together. we go. Now what we do is make sure we enable all the new vector 2s that we're going to set up on each of these, all of them. And then we'll have to do some rearranging as well, so it resizes. I should have thought about that before I copy and pasted them all. Jeez. There's an easy way to auto-organize, but sometimes that annoys me, especially when I'm trying to have everything on screen separated logically. Alright, there we go. All organized. Much better. So, let's start by adding the values for each of the sections. Let's just add a few comments first, just so we don't forget what we're doing. I was bad at doing that earlier. I've tried to be a little bit better at making comments going forward. This is our X movement area. This is the X direction. The 4-way directional movement, the 8-way directional movement. We'll just note the information. Now you notice that I'm only putting the comment around a certain box on that, so it doesn't put the comment in code at every single line item for each element. If you just put it in the first element, it'll put it at the top of the, kind of the top of the C# code, and you're not going to get it plastered in every other line of the code. You really only need it in the first line, and this looks a lot better in code generally. So what we do is actually need to set that array anew and how big it is initially. So we should probably do that. Let's go ahead and set that for each of the 4 directions. In the 4-way movement, it's a 4-way array, and we'll just select new 4-way array. For the 8-way movement, we'll select new and 8. And for the hexes, we have 6 and new as well. So what we want to do is create a list or array of game objects that we are creating, so we can use those later in finding the neighbors, and then we'll circle back around and fill in the directions. So here what we want to do is get a node list, right? So we've already done that. So what we want to do is really move that into its own method. We may need that later, we may not, but I think for good programming, we're just going to move creating that list into its own method. So notice over on the left we created a new method called getNodeList, and I copy and pasted it over and deleted it from the createGrid method. Clean it up, rename some of those local variables that got wonky on the copy and paste, and there we go, just delete that. And now we're just calling that method by itself. We can go ahead and delete that. That won't be used, the local child count in the createGrid method. It'll now obviously got moved down to the getNodeList. So that's a little bit better. Just a little bit of code cleanup. Make it a little bit easier to read. make sure everything still works. We're able to get our list. Now we'll go ahead and add the directions. So we have directions that we didn't really complete down here. We're basically starting at the center of the game object and reaching out up, down, left, and right of that game object 0 coordinates. And how far we're reaching out is the tile width plus the gap. But we already added the gap into the overall tile width anyways within the set tile gap method. So we just need to use the tile width here, and that works. So that's a 4-way movement. And then the 8-way movement has exactly the same thing on the first 4 indexes. So we just copy and paste them over, link them together. Down here, instead of 0 values for what was the X or Y, we're going to have really just the tile width or the negative tile width value. So that's the same now. Now we're going to go ahead and add the offset for the Y and X to get the diagonal hexes, I mean the diagonal squares. Notice as I connect into all of the values, the index values get cleared out or go back to 0, which is why I mentioned earlier that you want to keep an eye on those because they do switch back. 0, oh, it looks like I connected this to the wrong spot. Let me reconnect that. There we go. And then 0, 1, 2, 3, 4, 5, 6, 7. There we go. That should hook up our direction and get us ready for getting our node neighbors list later on. Thank you.